So that is elimination of arbitrary function of the form phi of u comma v equal to 0. Elimination of arbitrary function of the form. Previous class we have studied elimination of arbitrary function. Whatever function was given, we had to eliminate that function. But here you have a particular form, that is phi of u comma v equal to 0. If you have a function of this form, then you have to eliminate the function from a given equation. So, to form the partial differential equation from phi of u comma v equal to 0, where u and v are the functions of x, y, z, and z is a function of x, y, z, sorry, x and y, then by data, let me denote phi of u comma v equal to 0 as equation 1. So here phi of u comma v equal to 0, let me denote it as equation 1. So for u comma v is the function of x, y, z. Okay, and z is a function of x and y. So what we have to do is we have to differentiate this equation 1 partially with respect to x and y by applying a chain rule. Okay, why chain rule? Because phi is a function of u comma v is phi is a function of u comma v, and u comma v is a function of x and y. So that is why we need to apply a chain rule. Okay, so equation 1, I'll differentiate it partially with respect to x by applying chain rule now. So that will be dou phi by dou u into dou u by dou x plus dou phi by dou v into dou v by dou x equal to 0. Next, dou phi by dou u into dou u by dou y plus dou phi by dou v into dou v by dou y equal to 0. So here phi is a function of u is a function of x. Phi is a function of v is a function of x. If phi is a function of u is a function of y. Phi is a function of v is a function of y. Okay, so let me denote this as equation 2, which I've differentiated with respect to x by applying a chain rule. Let me denote it as equation 2, and let me denote this as equation 3, which I've differentiated partially with respect to y by applying a chain rule. Alright. So next what I have to do is I have to take the second term in equation 2 and equation 3. So which is the second term in equation 2? That is dou phi by dou v into dou v by dou x. So I have to take this entire second term to the RHS. So plus will be minus. So you get dou phi by dou u into dou u by dou x equal to minus of dou phi by dou v into dou v by dou x. Okay, so that will be your new equation 2. Similarly, equation 3 second term also have to take it to the RHS. So this plus dou phi by dou v into dou v by dou y will be equal to minus dou phi by dou v into dou v by dou y. Okay, then I have to divide equation 2 and equation 3, the new term, like after taking it to RHS, what new term you have obtained, I have to divide equation 2 and equation 3. So when you divide the two equation, dou phi dou u will get cancelled in the LHS, and dou phi dou v will get cancelled in the RHS along with the negative sign. So what will remain here? Dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. So whatever u and v is given, you have to differentiate first u partially with respect to x. So whatever dou u by dou x you have found, that you need to substitute here. Next, whatever v you have is been given in the question, whatever function is being given to you in the question, you have to differentiate that with respect to x. V you have to differentiate with respect to x, and you need to substitute it here. Next, you have to differentiate u with respect to y and v with respect to y. Substitute, cross multiply, and find the required partial differential equation. So we'll proceed with the first problem now. So given a function phi of x plus y plus z comma x square plus y square minus z square equal to 0. Okay, so now this is of the form phi of u comma v equal to 0, right? So by the data, this is of the form phi of u comma v equal to 0. So let me name this as equation 1. Alright, so let me name this as equation 1. So next, what is u here? U is equal to x plus y plus z, right? Compare equation 1 with the given equation. So u is x plus y plus z, and what is v? V is x square plus y square minus z square. Okay. So after writing what is u and v, we need to differentiate u partially with respect to x and y, and then we have to differentiate v partially with respect to x and y. So what do you get when you differentiate u with respect to x? Differentiation of x with respect to x is 1. Differentiation of y with respect to x is 0. But z with respect to x is dou z by dou x equal to 1 plus dou z by dou x means that is equal to p. So dou u by dou x is equal to 1 plus p. Next we have to differentiate u partially with respect to y. So differentiation of x with respect to y is 0. Differentiation of y with respect to y is 1. Differentiation of z with respect to y is dou z by dou y. But from our notation, what is dou z by dou y? We denote it as a q. So dou u by dou y is equal to 1 plus a q. Next, we'll differentiate v partially with respect to x and y. So what do you get when you differentiate v partially with respect to x and y? Dou v by dou x equal to 2x minus differentiation of x square with respect to x is 2x. Differentiation of y square with respect to x is 0. Differentiation of minus z square is minus 2z. Differentiation of z with respect to x is dou z by dou x. Denote dou z by dou x as we know from the notation it is equal to p. So you get 2 into x minus zp. 2 you can take it as a common term into x minus zp. Similarly, differentiate v with respect to y now. So differentiation of x square with respect to y is 0. Y square with respect to y is 2y. Z square with respect to y is minus 2z. Next z with respect to y is dou z by dou y. So dou z by dou y is q. So take 2 as a common term. So what will remain inside the bracket? So that is 2 into y minus zq. 2 into y minus zq. So next, let us differentiate equation 1 with respect to x and y. So what is my equation 1? That is phi of u comma v equal to 0, right? So you have to differentiate equation 1 with respect to x and y by applying a chain rule. Okay, this is according to a procedure what I explained before starting up with the problem. You can directly write it, okay? So what do you get? What is that? Dou phi by dou u into dou u by dou x plus dou phi by dou v into dou v by dou x equal to 0. Next, dou phi by dou u into dou u by dou x plus dou phi by dou v into dou v by dou y equal to 0. Okay. Or you can take this second term to the RHS. So plus will be minus dou phi by dou v into dou v by dou x. Okay. So I'll name this as equation 2. Similarly, from this second equation also, you can take this plus term to the RHS. So that will be minus dou phi by dou v into dou v by dou y. So let me denote this as equation 3. Okay, let me denote that as equation 3. So next we have to make a substitution. So before making a substitution, we'll cancel the term. So how can we cancel this dou phi by dou u? According to a procedure, we have to divide equation 2 by 3. So when you divide equation 2 by 3, dou phi by dou u and dou phi by dou u will get cancelled in the numerator as well as in the denominator in the LHS. And what will remain here? Dou u by dou x by dou u by dou y. Similarly here also dou phi by dou y, dou phi by dou v, dou phi by dou v will get cancelled in the numerator as well as in the denominator. So what will remain? Dou v by dou x, dou v by dou y. Now do the substitution. You know what is dou u by dou x, you know what is dou u by dou y. You know what is dou v by dou x as well as dou v by dou y. So dou u by dou x is 1 plus p, dou u by dou y is 1 plus q. Dou u by dou y, dou v by dou x is 2 into x minus zp, dou v by dou y is 2 into y minus zq. Now here 2 and 2 will get cancelled, cross multiply, so you get 1 plus p into y minus zq, 1 plus q into x minus zp. Alright, cross multiply and then multiply each term inside the bracket. That is 1 into y is y. Next 1 into minus zq is minus zq. Next second term you have to multiply to each term inside the bracket. So p into y is py. P into minus zq is minus pzq. Similarly, to the right hand side also you have to multiply 1 to each term inside the bracket and q to each term inside the bracket. So you get 1 into x as x, 1 into minus zp as minus zp, and q into x as qx, and q into minus zp is minus pqz. Okay. Will any term gets cancelled here? Yes. Minus pqz and minus pqz will get cancelled on both the side towards the left as well as towards the right hand side, and bring all the remaining term to the LHS. You can keep x as it is here. and you can take even this plus y to the RHS. You can bring minus ZP and plus QZ to QX to the LHS. So you can club the two terms together. So PY minus ZP, when you get it to the other side, that will be plus ZP. Next, minus ZQ already have in the LHS. It bring minus sorry, plus qx to the LHS, that will be minus qx. Alright, so p is a common term between the first two terms, so what will remain inside the bracket is y plus z. So p into y plus z, between the third and fourth term, take minus q as a common term. What will remain in the bracket is x plus z equal to x minus z. So this is a required partial differential equation. So now we'll move on to the next problem. Okay, so what is given in the question now? Phi of xy plus z square, comma x plus y plus z equal to 0. So by the data we have phi of u comma v equal to 0, right? What is u here? So what is u? Yeah, before that let me denote this as equation 1. Okay, the given data as equation 1. So where u is equal to xy plus z square and v is equal to x plus y plus z. All right. Compare equation 1 with the given equation, given function. So when you compare, in the place of u, you have x square, xy plus z square. In the place of v, you have x plus y plus z. Now we have to differentiate u partially with respect to x and y, and then we have to differentiate v partially with respect to x and y. So let's differentiate this with respect to x now. So differentiation of xy is y plus differentiation of z square is 2z into dou z by dou x, but dou z by dou x is p. So it's directly written as y plus 2zp. Next we have to differentiate this with respect to y. So differentiation of xy is x plus differentiation of z square is 2z into dou z by dou y, but dou z by dou y is q. Next we have to differentiate v partially with respect to x and y. So differentiation of v with respect to x with respect to x is 1, y with respect to x is 0, z with respect to x is dou z by dou x. So that will be equal to p. Next we have to differentiate with respect to y. So x will be 0, y is 1, z will be dou z by dou y. So that will be equal to q. Equal to dou v by dou x by dou v by dou y. Okay, so dou u by dou x by dou u by dou y equal to dou v by dou x by dou v by dou y. Rest all the terms will get cancelled. We have already found dou u by dou x, dou u by dou y, dou v by dou x and dou v by dou y. So what we have to do is we have to just substitute. So when we substitute, you get y plus 2zp by x plus 2zq is equal to 1 plus p by 1 plus q. So cross multiply. So when you cross multiply, you get 1 plus p into x plus 2zq is equal to 1 plus q into y plus 2zp. Now multiply each term inside the bracket. So 1 into x is x, 1 into 2zq is 2zq. Next p into x is px, p into 2zq is 2pzq. Similarly, I have to multiply each term in the RHS. 1 into y is y, 1 into 2zp is 2zp, q into y is qy, q into 2zp is 2pzq. So this is what you get. Okay. So what term will get cancelled here? 2pz will get cancelled. I'll keep y as it is. I'll take x to the other side. Bring 2zp and qy to the LHS. Club the p terms together and club the q terms together. So you get p into x minus 2z from these two. From this and this term. P, if you take as a common term between these two, so what will remain inside the bracket is x minus 2z. Between the second and this term, last but one term, if you take q as a common term, 2z minus q will remain inside the bracket. Okay, 2z minus, sorry, 2z minus y will remain inside the bracket. You can take q as a common term. Anyhow, here they have taken minus q as a common term. So if you take minus q as a common term, then y will remain inside the bracket. So y minus 2z equal to x minus y, y minus x also you can write. If you are getting minus y to the other side, then that will be plus x minus y equal to 0. So this will be my required partial differential equation. We'll move on to the next problem now. So f of x squared plus 2yz comma y squared plus 2zx equal to 0. So this is of the form f of u comma v equal to 0. Compare the two, denote this as equation 1. So where u is equal to x squared plus 2yz and v is equal to y squared plus 2zx. So denote this as equation 2. Let f of u comma v equal to 0 be equal to equation 1, and let u and v, whatever we have represented as, let that be equal to equation 2. Next, we'll differentiate equation 1 and 2 partially with respect to x and y by applying a chain rule. So you have f as a function of u and u and v are the function of x, y, z, where z is a function of x, y here. So apply a chain rule. So you get dou f by dou u into dou u by dou x plus dou f by dou v into dou v by dou x equal to 0. Or take the second term to the RHS. So that will be minus dou f by dou v into dou v by dou x. Okay, so you denote it as equation 3. Next, we have to differentiate partially with respect to y. So dou f by dou u into dou u by dou y plus dou f by dou v into dou v by dou y equal to 0. Or dou f by dou u into dou u by dou y equal to, take the second term to the RHS. So that will be minus dou f by dou v into dou u by, sorry, dou v by dou y. So that will be my equation 4. So this is my equation 1, this is my equation 2, this is my equation 3, and this entire term is my equation 4. So I need to divide equation 3 by 4. So when you divide dou f by dou u in the numerator as well as in the denominator, in the LHS will get cancelled and you get dou u by dou x by dou u by dou y, and in the RHS minus dou f by dou v will get cancelled in the numerator as well as in the denominator, and you get dou v by dou x by dou v by dou y. Okay, so we have not found this, so let me denote this as equation 5. After after differentiating equation 2 with respect to x and y, we can substitute it in this equation 5. So from 2 we obtain, we have to differentiate u with respect to x. So differentiation of x squared is 2x. Differentiation of y squared z is 2y into dou z by dou x. So dou z by dou x is p. So that will be 2yz. Okay. You can take 2 as a common term and write it as x plus yp. Similarly, have to differentiate it with respect to y. So you get 2 into yq plus z, and when you differentiate v with respect to x, you get 2 into z plus xp, and v with respect to y, plus 2zq. So we have to substitute all these in equation 5. Okay, take out the common term from dou u by dou x as well as from dou v by dou y. So 2 will get cancelled in the LHS as well as in the RHS. Cross multiply, so you get xy yp into y plus xq, and equal to z plus xp into yq plus z. So you have to multiply x to each term inside the bracket. So x into y is xy, x into xq is x square q. Similarly, yp to each term inside the bracket. So yp into y is y square p, yp into xp is y xy py. Next, you have to multiply z to each term inside the bracket. So z into yq is yzq, z into z is z square, xp into yq is xypq, xp into z is xpz. So what will get cancelled here is xyp q, xypq. Bring yzq and xzp to the LHS and take xy to the RHS. So you get y square minus, between these two, y square p and x at p. P is a common term, so y square minus zx will remain inside the bracket. So y square minus zx into p plus, between x square q and yzq, x square minus yz into q equal to, the remaining term goes to the RHS. So this is your required partial differential equation. Okay, you have few more problems in exercise of your textbook, so you can solve this problem. Thank you.